Hello everyone, welcome to my channel. Today we'll be looking at operators overloading and derived classes. Today's objective we learn about the concept of operator overloading, and then we learn about the concept of derived classes, and we learn how to implement inheritance and polymorphism. Now let's look at operators overloading. Operator overloading defines how operators behave for user-defined class data types like the classes and structures. So operator overloading in C++ can add special features to the functionality and behavior of already existing operators such as mathematical and other operators. So the plus operator, when used with variables of variable types, the int returns there are some. However, when used with objects of a user-defined type, it is an error. So here are some operators which we did, and we are revisiting them. So we have the arithmetic, we have the logical operator, then we have the relational operations, we have the pointer operators, and we have the memory management operator. We have types of operator overloading. We have the function overloading, and we have the operator overloading. Now, operator overloading, here is the syntax. So we have the return type operator symbol, we have the parentheses, the parameters where you put in an expression. Now let's take a look at operator overloading and the breakdown. So when we say return type, the return type of the function, we have the operator, that's a special keyword, and we have the symbol, we have the parameter. The parameter defines in the function. There are some forbidden rules or forbidden overloading rules which we need to take. We have the conditional operator, we have the scope resolution operator, the dot operator or the member sector, we have the pointer to memory operator, the object type operator, and we have the object size operator. We have the object alignment operator, and here are the symbols which you need to recognize. When you see, you recognize them. We also have to know that only existing operator can be overloaded. No new operators cannot be created. Existing operators cannot be renamed. At least one of the operands in overloading operators must be user defined. It is not possible to change the number of operands of an operator supports. Default precedence and association of operators are maintained. So here are some advantages of operator overloading. We have the simplicity syntax, allows the use of notation closer to the target domain. We have consistency, similar support to built-in type for the user-defined types, and easy to understand. And yeah, some disadvantage of operator overloading. We have potential misuse, as abuse or misuse can lead to unexpected behavior. Complexity, overuse or misuse introduce complexity and limit overloading. Now let's look at derived classes. Derived class is created from an existing class. The derived class inherits all members and member functions of the class. The derived class can have more functionality with respect to the base class and can easily access the base class. A derived class is also called a child class or a subclass. So we get to know that when you say derived class, which is also known as child class. Now let's look at this derived class definition. Begins with the keyword class, followed by the derived name class and colon, then followed by the access specifier, and the base class name. So this is the structure which you need to take note of. Now let's look at the derived class using access modifiers. Access modifiers such as public, private, and protected can be used in inheritance using derived classes. So here is a syntax. Now let's do public. If you say public, if a derived class is declared in public access, then the members of the base class are inherited by the derived class just as they are. Private, if a derived class is declared in private access, then all the members of the base class becomes private members in the derived class. We have the protected, the public members of the base class becomes protected members in the derived class. We also have the private members of the base class are always private in the derived class. So here's an example. Now let's look at inheritance. Inheritance allows us to create a new class from an existing class. The derived class inherits the features from the base class and can have additional features of its own. So the base class with the parent class, we can derive the inheritance. So the derived class inherits from the base class. So here's a code to demonstrate it. Now let's look at the types of inheritance. We have the single inheritance, we have the multi-level inheritance, we have multiple inheritance, then we have the hierarchical inheritance, and we have the hybrid inheritance. So the single inheritance is more of like a parent and a child. So when the parent is no more, the child inherits what the parent has. And we have the multiple inheritance, where you can see from the example, you will get property from your father's side and property from your father's side. So let's look at in family context. Yeah. So there's an example of the multi-level class, and then we have the hierarchical inheritance. They have the hybrid inheriting from different base classes. Now let's look at inheritance too. We have the static members. All classes dependent and are not inheritance. Friend class are not inheritance. Constructors and destructors are not inheritable. The polymorphism. So it means many forms, and it occurs when we have many classes that are related to each other by inheritance. It uses method inherited from another class to perform different tasks. It redefines the base class member functions in the derived class. So this is an example of the polymorphism class. So here's a code. Here's the code for it to understand it. So I'll end today's section here and continue in my next session, which will be coming up soon. Thank you. Goodbye for now.